today's topic is going to be wireless guest. So some of the things we'll talk about today, the goals of a wireless guest network, some of the methods we can use to achieve those goals, and then we'll be running through configuration examples of some of the most common guest setups that you'd run into and a lot of the features that you're going to want to be aware of. So first off, the goals of guest networking. In my opinion, at least, we have two major goals when it comes to a wireless guest network. First, we actually have a network that we want people to use. So we need the network to be, as easy to use as possible and as easy to support as possible. We want to give our users the best user experience that we can while meeting our other goals, and we want to not overload, the help desk or make it cumbersome on the back end to have to support this guest model. Now, the other major goal that we have, and oftentimes it conflicts with the first goal, is security. We want to protect our internal network from what's happening on the guest, because the guest is a little bit more Wild West in terms of oftentimes we're getting people on the guest network that we may not want depending on our security method, and we never can know the state of their PC. So even if they aren't a malicious user themselves, their PC may be infected with viruses or worms, or it's compromised in some way that could be used as a staging point to attack our internal network. So, oftentimes these goals are conflicting with each other in terms of an easy-to-use network that's easy to support, but also a network that is going to be secured and protect our internal corporate network from any potential attacks. So, how can we achieve some of these goals, and what's the solution that's ultimately going to give us the best of both worlds, at least as best as we can get? So the first goal of having an easy-to-use network is generally driven by what type of a network we have in terms of authentication. So, like an open network compared to, web redirects or, pre-shared key type networks. That's definitely going to drive the user experience in terms of how easy it is for them to use. So let's kind of talk about the different types of networks we could use for our guest network and some of the pros and cons of each of them. Now, the classic type of network that we use in guest is some flavor of an open network. So we're not using any sort of pre-shared key, we're not using AO2.1x or anything like that. So at the most basic level, it could just be a plain open network with no layer 3 authentication. So basically, a client connects, pulls an IP address, and boom, it's on whatever network you placed it on. The client doesn't have to do anything special other than saying, connect to this network. Now, from a client perspective, it's phenomenal because they don't have to do anything special, and especially when you start talking about devices like smartphones or tablets, where sometimes it can be a little bit of a pain to go through the web redirect process, and sometimes you actually lose your connection to the network and have to redo this over and over throughout the day if you're there for a long time. They love it, but it gives you zero control and zero visibility into your clients connecting. So all you really can see is their MAC address and, if you want to snoop in on where they're talking to. But we can't control who gets on our network, and we can't do things like, pop up an acceptable use page and say, you have to agree to this stuff before we let you on. So the lawyers typically don't like that. But if your company from a security standpoint and from a legal standpoint doesn't mind it, it's by far the easiest thing to support and by far the best user experience that you can get, but it's usually not an option available to you. Most of the time we need to get some sort of a layer 3 authentication method on top of that open network. So the two options we really have for that is we could just have just a generic, well, not generic, but we could, rather than force them to log in with user credentials, we can just redirect them over to some sort of acceptable use policy page. So they get on the network, they try to go out to a web page, they get redirected to this page of yours that tells them everything that they should and shouldn't be doing on your page, and they actually have to click accept. Maybe they have to type in some sort of information like their name or their email address or something like that, optionally. But they aren't required to put in any credentials. They just have to accept whatever you tell them. And so from a legal perspective, it's nice because the lawyers are happy because they've accepted some sort of agreement that they won't do anything naughty on your network, and that kind of covers their back ends from a legal perspective, I guess. But you aren't controlling who is on your network. So anyone can still get on your network just fine. It's a little bit of extra work. So it's still not limiting who can be on your network. So if it's important for you to do that, that's not really an option. Then you're going to move into the option of a full layer 3 web authentication, where they still connect up, redirect to a web page, but that web page is asking them for a username password. Now, that username password could either generally be shared across to everyone, so we just have one username password that every guest uses, or we could have a per user, a per guest username password authentication. So here we're at least somewhat controlling, either basically controlling who can get on, or we're enforcing a lot higher level of control over who can get onto our guest network. Obviously, with the shared username password, that gets to be pretty well known. Obviously all the corporate employees know it, and then they start giving it out to everyone. And so it's better than nothing. Some stranger just trying to sit in your parking lot probably doesn't know it, but it's not a secret. It's not a huge secret by any means. So we can keep some people off of our networks, but of the people that are on our networks, we can't really track too much. So it all looks like the same person to the network, just different MAC addresses. But it's very easy. We don't have to have this username provisioning process that every single time a new guest comes in, they go through the process of getting their own user account. So from a support standpoint, it's a lot easier to support and less work, but less control. Moving over to a per guest username password, now we have a lot higher degree of control. Typically these per user or per guest user credentials are also expiring, so they're only valid for a certain lifetime. So even if it does get out in the wild, it's only worthwhile for a certain period of time. So we get a lot higher degree of control over who can get onto our guest network, but with the added cost of the back-end expense of, now we need people that can actually provision these guest accounts. Maybe it's, one or two people that are up at the front desk, or it could be, every employee has the ability to do it. So, there's training that goes along with, getting people, taught how to use the system to provision the credentials. And it's a little bit more support on the back end when something's not working right. But usually one of these three things, plain open with just an acceptable use page, or open with a full web login, credentials, and you can optionally throw in an acceptable use page on the end of that as well. Is typically where we're falling in somewhere in that, because the pros and cons of these, on an open network, any client can connect to an open network, so that's usually not a problem. Adding in the web redirect usually works for most any guest type device anyways. A guest device is going to be some sort of a laptop or a tablet or something like that, so they all have web browsers, and they should support that usually fairly easily. And another reason that's nice is that usually when corporations write policies on their laptops, some corporations will actually enforce policies on their laptops to say, these are the types of networks we're going to allow our corporate assets to connect up to. And if they want you to connect up to a guest network, they're going to assume the guest network is some flavor of an open network. So policy, as long as the corporation is cool with you connecting to guest networks, will allow that open network connectivity. Some of the downsides, though, to the open network is, a real common downside is DHCP starvation issues. So if you have a real big facility and you get lots of people walking through it, oftentimes, our phones or whatever will automatically just connect up to an open network. So even if they don't ever authenticate, you're doing some sort of a username password authentication, even if they don't authenticate, they still use an IP address. So if you have enough of these people in your facility, like a hospital or a college or something like that, where there's just tons of people always milling through, you can quickly burn through your IP range pretty fast. So oftentimes in those types of areas, you need really big DHCP scopes, and you really need to drop down the lease time so that those leases are always being given back as long as those people, once those people leave. It doesn't take very long for the DHCP address to get back into the pool and available to someone else. But it is something that people oftentimes have to fight in these types of environments. There is no encryption over the air on an open network. Now, normally there's no expectation of encryption over the air, so that's not that big of a deal, honestly. If people want to get encryption over the air, that's usually where you'd say, okay, just spin up a VPN connection to your company and then everything going across that VPN connection is encrypted. So if you want some sort of a security, that's one way for them to get the security. But again, it's not expected, so it's not really that big of a deal not to be providing encryption across the air. So yes, a few pros and cons, but there's a lot more pros to it, and the pros really drive towards why we use these as our main method of guest networks. A few other options though we have for guest networks. Oftentimes I'm asked when I was back in the corporate world, or sorry, in the Cisco partner world, people would say, well, how about a WPA pre-shared key network? So that has a few positives around it. So with a WPA pre-shared key style network, we get some form of an authentication, so it's akin to that shared username password that we would have in the open network side. So it's the same key for everyone, but it's still a password, and it's better than nothing. So we are somewhat controlling who can get on our network with the pre-shared key network. Once they're on our network, we're giving them encryption. So that's an added bonus, you would think, to your guests, a little service you can provide to them. And it also helps prevent against that DHCP starvation attack. People don't pull an IP address on a WPA pre-shared key network until they actually authenticate up to the network. So if you don't authenticate, you don't pull an IP address. So you don't have to fight that DHCP starvation issue if it is a problem in your environment. So you're thinking, okay, great, what's the downside? Because all I'm really seeing is positives here. Well, some downsides you can run into with a pre-shared key style network. One, not everyone's going to be able to connect to it. It could be a corporate policy thing where they don't allow you to connect up to pre-shared key style networks. Very, very small percentage would fall under that. Some people might not be as savvy with using their supplicants. Some supplicants are better than other supplicants in terms of how it would interact with you. Some will just pop up and say, okay, what's pre-shared key? And you type it in and boom, you're good. Some of them are a little bit less so in terms of their ease of use. So it requires a little bit of extra savvy on the guest user standpoint. But other than that, those are the main two detractors there. But still, we try to drive towards those open networks. But if you really needed to target a few of those things, especially like the DHCP starvation attack issue, that might be a decent alternative to an open network. Now, adding in layer 3 on top of that, if you actually still need to do acceptable use pages and stuff like that, that adds on another layer of complexity, and we won't really get into that today. But that is another thing that you're going to need to sort through in terms of that. The other thing that we could really do would be like a WPA with an EAP authentication, and that's just really not very viable. That would be, you want some sort of security, you want to prevent this DHCP starvation attack, and you also want to do a per user or per guest user credentials. Well, that EAP would, I guess, would give you that. But then the battles you're going to fight with EAP is, okay, well, what EAP type are we going to use that everyone supports that pretty much drives you towards PEEP? Because EAP TLS, we need a client certificate. There's no way we're going to do that. And EAP Fast and LEAP aren't supported across every client. So, okay, now we're using PEEP. And now we have this server certificate that's going to be pushed down to the client for the client to validate. And not every client is going to be able to validate that. They're going to be getting cert warnings probably, unless you have a publicly signed cert signing your radio server cert. So almost never done there. So I would say either do some sort of an open network, or in specific instances that you need to target specific issues, you could do a WPA pre-shared key network. But I wouldn't ever get into an EAP style network. And I definitely wouldn't do any sort of web stuff because that's pointless. All right. So those are some of the ways, some of our options for our guest networks and some pros and cons for those. Now let's talk about the design of our network and getting that security. So the main tool that we have to give us security in terms of protecting our corporate network from the guest network is going to be separation. We want to separate that guest network as much as possible from the corporate network so that they never really interact with each other except through some sort of controlled point of access between the two networks that you can have a heavy amount of control over what, if anything, those guests are able to communicate to on your corporate network. So we'll talk about the different types of designs that can achieve that separation, pretty much from best in terms of the most secure methods all the way down to sort of the least desirable secure methods. Okay, so what's going to be the most secure method? I'm going to start drawing some of this stuff out, so let me flip over to another view here. So the most secure method that we're really going to have in terms of that separation would be completely separate wireless networks. So we have a wireless guest network and we have a wireless corporate network. Now, no one does this for a very good reason. If you have two separate networks in the same RF space, they're going to be competing with each other. They could see depending on how you have things configured, they could see each other as rogues. Even if they aren't seeing each other as rogues, they're going to mess with each other from an RRM standpoint or an interference standpoint. So no one does this. It's not really a valid option. So how can we get that separation while having a shared, one AP supports both corporate and guest? Well, the best solution, and this is the one that Cisco is going to drive you towards, is to have your internal controllers where all your access points are located, and then you have a DMZ, and within the DMZ you have wireless LAN controllers there, and you tunnel those guest clients to that DMZ controller. So what would that kind of look like here? So up here we have a DMZ, and we have a wireless LAN controller. In between the DMZ and your corporate network, you probably have a firewall. And then down here we have corp with, one or more wireless LAN controllers. And we have a bunch of APs. They're all up on these internal controllers in the corporate network. So all the corporate networks are just dropping off locally on the controllers, but our guest networks can be using the mobility anchoring feature. And so those would tunnel up the guest network specifically to this wireless LAN controller that lives in the DMZ. So what will happen is a client connects up to the access point. The access point sends it up to its controller via CAPWAP. Instead of dropping it off locally, the controller then tunnels it through an Ethernet over IP tunnel to the wireless LAN controller in the DMZ. And at that point, they drop off on the network. So the clients logically live in your DMZ, and you control your policy using a firewall, which is an advanced security device. So it's it's a staple firewall. It can do deep packet inspection. Very easy to control policy using a firewall. You already probably have enough policy in place to protect yourself right off the gate. But with the firewall, we're saying, okay, what if anything can these guest clients talk to on the corporate network? So the clients never even live technically in the corporate network. They live in the DMZ from a logical standpoint. So it's very secure, and we can use something like a firewall to control the policy of what these clients can talk to, if anything, on our corporate network. So by far the most secure method we have. The downside to this is that we have to buy additional controllers that live in the DMZ. So from a cost perspective, we're buying additional controllers that sometimes APs never even associate up to. Historically, we've also had to buy the more expensive controllers, 4400s, 5500s that can terminate these tunnels. With today's code, we can do that with a 2500 series controller. So now it is even more affordable to do, which is a nice change. But historically, it has been a bit of a price jump to have this DMZ model here. And another nice thing about this DMZ model is it spans multiple sites. So not only can I have, if this was, site A, can tunnel to this DMZ, I can also have sites, B through Z over here with their controllers tunnel across, some sort of a WAN connection and drop off into the DMZ. So this can scale to many, many sites if you want, or you could have, in a very large design, you could sort of have an East Coast DMZ, West Coast DMZ type thing for redundancy or whatever it's going to be. But the awesome thing here is you only have to apply policy in one place. So no matter how many sites, if they're all funneling into the DMZ, I only have to apply policy at this DMZ firewall, and that makes life a lot simpler. If I had to apply policy in 20 different sites, it's a lot easier for me to goof up the policy in one of those sites. Or if I needed to make a change, I had to make a change across 20 different sites. So from an administrative standpoint, it's awesome and it scales really, really well. But again, the one downside is that you have to buy additional controllers. And I guess, here you actually have to have a DMZ for this to make it work. So on a very, very small location, it might not be a possibility just because it doesn't have a DMZ or whatever. But that's definitely the best option in general once you get at least to a medium-sized network. And that's generally where you want to try to drive to because it's going to give you, the best results from a security standpoint as well as administration. Massive amounts of scalability. It's a pretty good design. If that's not available to you because either you don't have a DMZ or more likely cost becomes the factor, you just can't justify the cost of yet another controller just to terminate this stuff. We do have some other options that are still pretty good. Another option that we have, we pretend we still have a DMZ and we have a firewall. And then we have our corp network. We'll just draw one controller here. So we have our internal controller with our APs on it. And what's going to happen on here is now we don't have this other controller that we're tunneling up to. So we have to drop this traffic off locally. But what we can do is rather than just drop it off of some network that's routed internally in the corporate network, we have two options here. We can either have a separate interface on the wireless LAN controller that plugs into a switch in the DMZ, or if the DMZ is so small that the DMZ really is the firewall, it could plug directly into the firewall itself on a specific port in the firewall. So in that respect, on the wireless LAN controller, we would drop it off on a specific VLAN, and that VLAN is assigned to an interface, and that interface is just wired all the way into the DMZ. So technically, you're dropping it off directly into the DMZ. So we still get the benefits of the firewall controlling policy in terms of what can talk into our corporate network from the DMZ to the corp. But it's a little bit more limited in that, one, this design requires some sort of a layer 2 connection up into the DMZ or up to the firewall device itself. So if we want to string a physical wire, if it's copper, we're limited to that 100-meter copper distance. If it's fiber, we can go a whole lot farther. Another way you could do it would be if you didn't want to have a separate physical connection. Back out of this. We could just drop it off on a VLAN. So if we had a switch here, we would drop it off on a VLAN that plugged into the switch, and then ultimately the switch itself could either plug into the DMZ or into the firewall directly. So if the controller isn't close enough to the firewall to do it, we could, as long as we had a layer 2 path somewhere through our network and that VLAN was unrouted. So the VLAN just trunked all the way up to the DMZ or all the way up to the firewall. That's another way to get around that distance limitation. But ultimately what's happening is one way or another, we're dropping the clients off on a specific VLAN, and the only place that that VLAN goes is directly into the DMZ. So we're still living in the DMZ. We're still controlling policy through a firewall. This doesn't scale nicely like the last one did. If we had site B over here, it's extremely unlikely that you have a layer 2 connection between site B and C and D and D and so on to where your DMZ is. So sometimes you do, but oftentimes you don't. So this doesn't scale across any sort of layer 3 boundaries. And typically we have layer 3 boundaries across our WAN, but again, not always, but oftentimes we do. So it doesn't scale as well as that other solution does. So if you had to replicate this at every single site, that means every single site needs its own DMZ. And it also means that you're applying policy in every single site. So you're not generally applying policy in one spot anymore. You're applying policy in many different spots. But you don't have to buy another controller. And this works honestly really well in just a really small network. I've used this method in small networks before, like a school or something like that, where cost was a big factor, so they couldn't justify another one. But they did have a firewall. And so Sure. You know, the wireless LAN controller is not that far away. We just pipe it right over. And we still get all those benefits of using the firewall and having a DMZ. So it's easy to control with policy. It just doesn't scale very well. So a question, couldn't you still build a mobility anchor in the HQ controller and drop the client off on the DMZ VLAN? Yeah, that's a good, that is a good option. So that would help it scale. Yeah, that's a very good suggestion. So that would help with that scalability option. So that is definitely something that you could do. Now, oftentimes, if we are scaling to a large number of sites and we have controllers in every other site, you probably can afford to buy one more controller and put it in your DMZ. So once you start getting into that scale question, I would hope that you could afford that extra controller, but if you couldn't, that would be a decent solution, yeah. Tunnel it to the controller in the corp and then drop that off into there. So, good suggestion. Another way that we could kind of achieve this that's a little bit more scalable would be, so rather than dropping off on a layer 2 VLAN that lives in the DMZ, we can control separation through VRFs. So with virtual routing and forwarding, if you're familiar with that, basically we assign different ports to different VRFs, and each VRF has its own unique routing table within a switch. So a switch could have a guest VRF and a corporate VRF, and the guest VRF would have only the networks that would lead it into the DMZ or to a firewall or something like that. So the route table lookups would funnel it into the DMZ, because in the guest VRF it wouldn't have any of the networks that are in the corporate network. Now this is a solution, yeah, it does provide separation, but typically the switches that are used with VRFs are pretty expensive. Most oftentimes, so you're buying like 6500s or these big bulky switches that cost a lot of money, and usually if you can afford that, you can afford a controller in your DMZ. So most of the time, while it is an option to give you separation, if you can afford it, you can afford a controller probably in your DMZ. The last option really is pretty much just pretends you don't have a DMZ or you can't get to a DMZ. So with the last option, really all we're doing is we just drop the traffic off locally, and the VLAN and subnet live in your corporate network. And so what you do is you just create an ACL and apply it to the SVI, that's the default gateway of this corporate or of this guest network. And you use the ACL to say, okay, these are the things that you can talk to, and these are the things that you can't talk to. And you just have to make sure you write your ACL well enough so that you don't accidentally allow unintended access into your corporate network. So if it's a real simple ACL, it's pretty easy to control. But the longer that ACL gets, the easier it is for you to miss something. And it's hard to test everything unless you have some really established penetration testing type tools in your network. So I always use this as the last resort. So if I don't have a DMZ that I can get access to, I'll use this. So most of the time, smaller networks is where I'm doing this. But the downside here is, you have to write these ACLs for every single guest network. So if you had 10 sites, you would have to write 10 different ACLs, and it's a lot easier to make a mistake when you start talking larger numbers like that. So that would be the last resort in my opinion. As much as possible, I try to get to a DMZ and try to be using something advanced, more like a firewall or something like that, to control my policy. But an ACL works everywhere, so it's always something available to you pretty much no matter what your network is. Okay, so enough about the background here. Let's actually get into some demonstrations of the configurations. So in my network, I have a number of controllers here. We're going to start off on controller 2. So on controller 2, I have a couple of access points. So I have 2 access points on my controller. And I have a layer 3, a dynamic interface, so I have a VLAN 13, so I can drop traffic off locally. So we'll pretend a single controller set up here. All right. So usually the first thing, I have my interface to drop it off onto, so VLAN 13 will be my guest interface. So let's just look at some of our options in terms of the web pages that we can be using. So the web pages for internal web authentication, it's going to be under Security, Web Auth, Web Login page. So we're going to have a couple options just built in to use the controller as our web server. So when we do these layer 3 web redirects, the controller itself is actually the web server, so it's the one providing the web page to the client. So we have this default internal web page. Looks pretty ugly. If you haven't seen it, this is it. So, not customized to your environment at all. The most customization you can do is you can change this text here. So you can change the bolded text up top, this down here, and the little Cisco logo on the top right. You can turn that on and off. But that's all you can do. So if you wanted to tweak that, here's where you can show or hide. The headline is the bolded part, and then the message is down there. Hi there. Thanks for coming. So if I apply that, now I can see that here's my custom message. So that's about all you can do with that, but it's simple and it's always available to you. The other thing that we can do for an internally served web page is going to be a customized. So rather than just using that really generic-y looking web page, we can actually code our own web pages and install them on the controller, and I'll actually demonstrate that a little bit later. So now we can actually create web pages that look like the rest of our corporate web pages, and we can put our own images and look feel to it, but it's still being served up by the controller. So that's a decent alternative if you don't want to be directing them out to some sort of external web server, which is the last option, external. So here, rather than serving up the website on the controller, we actually send them off to some external web server. The external web server is then responsible for providing the web page as well as any sort of authentication measures. So both the web page and the authentication are happening off of the controller on an external redirect. So that's not very common, the external web redirect, except in maybe larger environments. But we'll start off with the internal. And the one last thing you can do here is we can do this redirect URL after login option. So normally what would happen, my web client comes up, I try to get to google.com, it redirects me to the web login page, I log in, and then normally it would go ahead and let me go back to google.com. Well, if you want, you can actually say, after you log in, I'll send you to a web page of my choosing, so you can have your own yourpage.com. And then after they log in, they get redirected to yourpage.com or whatever it's going to be. Oftentimes it's our corporate web page or whatever it's going to be. So that is one option there. So we'll go ahead and start off just using the internal default username web page. Now, if we want to do a username password authentication, another thing that we're going to need to have up and running is a username password to authenticate with. So that's going to be, if we do it locally on the controller, it's going to be controlled under this local net users, so security, AAA, local net users. New, and then I could just say, do guest1 with a password of guest1. Now if I do it just like this user account is permanent. It does not expire, so it would be good for forever. If I check guest user, this makes it a limited lifetime user account. So after so many seconds, this account will expire. So typically I'm going to do this if I'm giving per guest user credentials. If I want to have just a shared username password that's used across everyone, most of the time then I would make it a permanent account. And that way I'd never have to worry about it expiring. So I'm going to leave it as a permanent account here. The other option we have for authenticating is we can actually send this off to an external web server like ACS, external radius server like ACS, and the ACS, or the radius server, could do the authentications for us and send back a response, yay or nay, to the wireless LAN controller. So we'll show you both of these as well. All right, so let's go ahead and just do a real basic web page, or WLAN. So let's create a new WLAN. Call it guest pod 1 since I'm on rack 1 over at Proctor Labs there. Let's turn it on, and I'll go ahead and assign it to VLAN 13. So the client should pull an IP address in VLAN 13. So this would, typically on a single controller solution, this would be the unrouted VLAN that I try to get into the DMZ or to the firewall. Otherwise, this would be the VLAN that I apply the ACL to control what the guests can talk to and what they can't. We do none for layer 2 security. And then we go ahead and turn on the web policy for layer 3. So we're typically only going to use one of two options within here, 90-odd% of the time. It's going to be authentication if we want to have them put in a username password. Or if we don't want to require a username password, we just want to give them that acceptable use page, that would be pass-through. So we'll show you pass-through real quick, and then we'll show you the authentication. With pass-through, locally on the controller, we do get the option to ask for an email address. So a client would have to, on the acceptable use page, type in whatever their email address is. So if you want to collect that, check the box. If not, just leave it unchecked. And that's honestly all we have to do to get guests. But some of the other things that we'll commonly do with QoS, we'll put them in the bronze quality of service queue, so they have the least priority access to our RF network. So our internal devices would get better access since they'll be at silver typically, or even higher if it's like VoIP or video or something like that. So we'll knock them down to bronze. Other things that we might be doing, session timeout becomes kind of important, especially when we do these layer 3 web policies, because the session timeout basically says, once you're up on my network, I start a countdown timer, and after that countdown timer runs out, I de-authenticate you, and then you have to do a full re-authentication. And what that's going to imply is that they have to do whatever web authentication, whether it was pass-through or web auth, they have to do that all over again. So if it's a short time, they're going to be keeping on, getting redirected to a web page to re-log in. So on a guest network, typically what you want to do is jack this up to, at least something like, 2 hours, 4 hours, 8 hours, whatever your average guest stay is on a given day. So they're not always having to, re-authenticate and redo that web redirect. So I'll go ahead and jump them up to something higher here. A little bit more reasonable. I think this is maybe 4 hours or something like that. So, or you could flat out turn it off. I don't know if I would do that, but definitely at least get it higher than 30 minutes, because otherwise every 30 minutes they're going to be doing a web redirect, and that's frustrating from a user standpoint. Some other things you could do in here, you could do like a DHCP address required, so you're not allowing them to use static IPs, because what guest would ever use a static IP on your network? That's a common configuration. A lot of this other stuff is just personal preference type things, but those are two common things that you might want to do on a guest network. Another one that might be kind of common with a guest network, peer-to-peer blocking. If you want to at least give your guests a little bit of security, even though it's an open network, you can prevent at least a wireless client to wireless client attacking or something like that by setting the peer-to-peer blocking to drop. And that's generally pretty safe on a guest network, because there's usually no peer-to-peer stuff going on a guest network. And one last thing I've seen people do is on the radio policy, sometimes they say, okay, guests, you're only on the 2.4 radios, and I reserve my 5 gigahertz radios for my corporate stuff. So that's another way of preventing a guest client from messing around with your corporate stuff. So now your corporate devices don't have to fight for bandwidth alongside of guests. So another option that you could use for your guest clients. Now, as we move forward with some of our technologies like 2.11 AC, that's a 5 gigahertz only technology, and a lot of these newer technologies are probably only going to be 5 gigahertz. So now, while these new clients should be definitely backwards compatible, you may or may not want to force them onto the 2.4 network, just depending on what sort of client experience you want your guests to have. But it is a way to enforce separation. Okay, so we'll go ahead and just leave it at all. Okay, so now I should be up and running. I have a guest network with a pass-through, so it's just going to send me to the acceptable use page. And then as long as I accept, I should be up and on my way. So let's kind of watch a client associating it and just see what the process is. Does the DHCP lease time affect the client session timeout? No. So the DHCP lease time just says how long is my DHCP lease valid for. So within a given client session, if my client session is 4 hours long, if the DHCP lease time is 1 hour, usually at the halfway mark is when they re-up, so they'll re-up every half hour. And that's fine. That's usually pretty quick, and that won't force them to do, another web redirect or anything like that, because they should be getting the same IP address every time. So that shouldn't affect, that redoing the web logins or anything like that. So pretty independent. Okay. So I have a client out here. If I can get up to it. And I'm just using the AnyConnect client, so let's see. I already had it remembered, so I've already even connected. So I've connected up. I've got an IP address on 10.10.13.150, so on VLAN 13. So let's look at my client session and see where we're at. So if I go to Monitor Clients, there's my client. So right now it is in this WebAuth required state. Generally, a client's going to go through 3 different states that you could possibly see on your controller. To begin with, it'll connect up. Before it gets an IP address, it will be in a DHCP required state. Once it pulls an IP address, then it will move into this WebAuth required state. Now in the WebAuth required state, it can't do much of anything. Basically, this is the state that you get prior to it, fully authenticating. So, before that web redirect happens, it'll be in that. Even after the web redirect happens, but before you've logged in, you stay in this WebAuth required state. Now in the WebAuth required state, or the previous state, until you fully authenticate, there's really only 2 things you can do by default. 1, you can pull an IP address, so you can do DHCP stuff just fine. Number 2, we can do a DNS resolution. So we could resolve www.google.com or whatever it is. As long as you learn about a DNS server, you can do those DNS reservations. But that's it. Until you actually fully authenticate, you can't do anything else. So in order to get the web redirect to happen, then what you would do is you'd go to your client, open up your browser, and normally what you would have to do is you would have to type in a URL. It has to be an HTTP page, so port 80, HTTP only, HTTPS won't work. Non-port 80 stuff, that won't work by default. There's a couple other ports you can turn on, like 8080, or there's one other port that's kind of common with proxy servers. But normally, what we're talking about, port 80 web page, and then you would have to type in a resolvable DNS name, so www.google.com. Now my client is not on the internet, so I can't reach out to any real web pages, and I don't really have any internal web pages that I can do. So if you don't have an actual DNS name you can type to trigger this web redirect, the other thing you can do, just for our testing purposes, is type in the virtual interface IP address. So for my controller, my virtual interface IP is 192.0.2.1. 1111 is a real common IP address. So for your testing purposes, you can do that, and that's what I'm going to have to do. But normally in your networks, they have to type in a URL with a DNS name, and that DNS name has to resolve. So that implies that the clients have to learn about a DNS server, at a minimum, and possibly, a DNS suffix for them to use. And then they're going to have to reach out to some address that whatever server you taught them knows. So if they're using your DNS servers need to resolve the IP address. Or if you kick them out to like Google's DNS server or some sort of public DNS server, it has to be a public URL. So if they try to get to their internal corporate web page, that wouldn't work because it's not resolvable by an external DNS server. So once we get the redirect, it's going to redirect to an HTTPS page, and by default, the cert used for the HTTPS page is just a self-signed cert. So they're always going to get this this certificate error. I can kind of show you a little bit later how to try to get around this certificate error by installing a public cert and doing a couple other things. But we'll go ahead and just step through the cert error. And you'll see that the address that I was redirected to, if you can read it, I know it's a little small on here, it's https:// the IP address of the virtual interface on the controller. So on the controller, if I look at my interfaces, my virtual interface, this is the IP address used for serving up a web page on the controller. So this is where they're getting redirected to, 192.0.2.1 in my case, or whatever your virtual interface IP address is going to be. So normally we'll actually see the IP address in the URL by default. So since I did a pass-through page. I don't have to type in a username password. All I have to do is hit accept. Once I hit accept, that's the end of it. Now my client would move into a run state. So if I go back to my client, we'll see them at oh, still not quite through yet. Let's see. There we go. Now let's refresh. Just took a little bit. There we go. Now my client moved into a run state. The restrictions I had before in terms of what I could talk to have been removed, and now I can talk to anything that I'm allowed to talk to on VLAN 13. So that's the client progression. DHCP required, WebAuth required, and then finally into a run state. So, pretty simple there. I'm not controlling who can get up onto my network, but I am at least forcing them to accept some sort of acceptable use policy. Now let's flip that over and do a web authentication instead of pass-through. So, sorry, if I go to my WLANs, we'll just flip it over to WebAuth. So layer 3, authentication. Okay. And then all I would need to do is just bounce my client session, get it back into fresh state. It'll be in a WebAuth required state, so let's just remove them. And we'll just go ahead and attempt to reconnect. All right, might have already done it, so let's check now. All right, so I have my client session back in a WebAuth required, so let's go ahead and just trigger that redirect one more time. HTTP, the virtual IP address, otherwise, a fully resolvable DNS name. I think since I still have my web browser open, I don't have to suffer through that cert warning since I've already accepted it once, but we'll see. There we go. Now I need to type in my username and password. Guest1 was the user account that I created. There we go. So those are the two different main methods we have for web. Pass-through only, or an actual username pass-through, username password option. All right, let's say I wanted to actually kick out my authentication out to an external Radius server. To do that, first we're going to have to define our Radius server. So I'm going to configure a Radius server under Security AAA Radius Authentication. Create a new one real quick, and I have an ACS server out there at 10.10.2.10.5. And I just need a shared secret here. And then on my Radius server, I'm probably going to have to relog in here real quick. Then I can create a username password on my Radius server. So this is ACS 5.2. You can see a different interface on ACS 4 or ICE is a little bit different as well. But the steps are going to be basically about the same. We have to define our network device. So who's going to reach out to us? Looks like I already have one in there. Let's create another one, WLC2, 10.10.112.10, so the management IP address, and that shared secret. Create a user account to log in with, so let's see if I have a user. Okay, let's create a new one called ACS guest. Same password. We'll see if this works. And then just a real simple policy that's going to allow this authentication. I think I should already have this in place. So, whoops, in access policies. I should be already set to use internal authentication, and I have a default rule that's going to permit. So this will give me just the generic permit that I need. But on the controller side, oops, what we need to do is once we have our Radius server here, we just go back into the WLAN, go to security, and then we go over to our AAA servers and we'll call out the server that we want to use, and then down below, just make sure that the Radius server is in this used for authentication list here. So we see right now it's going to try local first, and then it's going to reach out to Radius, and then if I actually had LDAP servers, it would reach out there. So that's fine. So as long as I use an account that's not on the local controller, it's going to fail over to Radius, and then we should be good. And since I have I don't have an ACS guest account here, it should move over to Radius. So let's try to kick that off and see if that's working. Again, we'll just remove our client session, force a brand new authentication attempt happening here. And we'll just give it a second to reconnect. There it is. Again, we should be in this web auth required state because it did pull the IP address pretty quick. So now I should be able to kick off the web redirect. And this time just put some different credentials in there. So ACS guest, submit. Login successful. I should see now I'm in a run state. And if I really wanted to, I could go over to my, my ACS server and see in the logs that I had, a Radius request. Now, by default, it's going to use PAP as the protocol that's used in this authentication. So you just need to make sure on your whatever Radius server you're using, you're allowing PAP as a protocol to be used. If you want to change what protocol is used on that external, keep on doing that, sorry. External lookup, that would be controlled under controller. And the web Radius authentication, you could choose CHAP or MD5 CHAP as an alternative to PAP, but PAP is the default. And sometimes this takes a while for me. If I look at my Radius authentications, I should see an entry for that web auth attempt that I had. So still we have an internal web page, but we're sending that authentication attempt out to an external Radius server. And this would typically be done for a couple reasons. If you want to do a per guest user credentials, you could populate that onto the Radius server, and then that guest would be accessible on every single. It doesn't matter what controller it's coming from because they can all point to ACS or your Radius server, and now you only have to populate that user account in one spot. And the other benefit here is if you just wanted, maybe a little bit better logging. You're already logging Radius requests and probably have a system in place for that. Now you can also get your guest authentications in the same place that all your internal authentications are happening as well. So now you get all of your logs in a central spot. So that's another benefit that you can use for ACS authentications. But there it is. Again, we can see it's PAP ASCII. There's the user account that I use. So that's the example of external authentication. And the last thing we'll show you before we get into a dual controller setup would be the Pre-auth ACL. So as I had said before, the only thing you can do by default once you get connected up when you're in that web auth required state is DHCP and DNS. Let's say you want to allow your guests to do additional stuff before they actually authenticate. Sometimes you might want to do this if you're using your guest network as sort of a BYOD network, and so maybe on the BYOD sort of guest network, you would open up access, maybe to your mail servers so that, PDAs can at least connect up, pull an IP address automatically, and get email, company email, without having to do that web redirect, which is a real pain in the butt on a smartphone. So whatever the reason is going to be, basically what we're going to do is we're going to create an ACL and apply that as a pre-authentication ACL. So we're going to find that under security, access control lists. We'll create a new one, call it pre-auth. And then we just need some permits. So whatever we permit will be allowed before authentication. Anything that's not permitted will not be allowed. Pretty self-explanatory. The one thing you need to keep in mind as you do a pre-auth ACL is that in order for a web redirect to be triggered, it actually has to hit a deny. So if you just allowed all HTTP traffic, you would never get a web redirect because it has to have a failure, in a web lookup or a web page attempt. So if you need to allow some web activity, Just make sure you explicitly allow only the web pages that you want them to get to, and then that way any other web pages would kick off the web redirect. But let's just say something real simple like I want to allow them to ping stuff on their, or talk to stuff on their local subnet, just as an example. So we'll say they are on the 10.10.13 network. So if it's from the 10.10.13 network, destined to the 10.10.13 network, doesn't matter what protocol it is, we'll permit it. Everything else will be denied. So if I re-auth real quick, or reconnect, before that I can actually show you that it doesn't work, and then we'll turn it on and show you that the pre-auth ACL kicks in. So clients, let's get rid of this guy. Force him to re-authenticate or reassociate and start the process over again. All right, so once I get an IP address, okay, I have. I could just do something simple. Pull up a command prompt. Try to ping my default gateway 10.10.13.1. Doesn't work. That's what we would expect. Now let's go ahead and configure that pre-auth ACL. So we go into our WLAN security layer 3. And then in the pre-auth ACL down here, we just go ahead and specify the ACL we want to use. Apply. All right, now we'll bounce our client. Oh, looks like it got bounced for us when I made that change. Okay, now it's back on. Pre-auth ACL should be in place. Let's see if I can ping. There we go. But I would not be able to ping off subnet, for instance, 12.1, because the pre-auth ACL is denying it. Now if I try to go to, trigger my web redirect, since it's hitting a deny rule, the redirect actually happens. And with an ACL, you never have to have an explicit deny. There's always the implicit deny at the end, just like a normal iOS-based ACL. So ACS guest, ACS guest. And once I do this, I move to the run state, the pre-auth ACL is removed, and at that point, I should be able to ping off subnet. There we go. So that's an example of using a pre-auth ACL. Okay, so now let's get into the dual controller scenarios where we're tunneling our guests into a theoretical DMZ controller. So we'll pretend that WLC2, the one that I've been on this whole time, is our internal controller, and then we'll make WLC1 our DMZ controller. So the technical terms for these would be the internal controller is your foreign controller, and the controller that lives in your DMZ, the one you're tunneling it to, is referred to as your anchor controller. So if you think of like a layer 3 roam, normally once you start on controller A and you layer 3 roam to controller B, controller A keeps an anchor entry of the client and controller B gets the foreign entry. That's where the anchor foreign entries or names come from. So rather than anchoring it on WLC2 where it initially starts, it's going to send that anchor entry all the way up to controller 1. And then controller 2 will have the foreign entry. So the client could then roam between foreign controllers, controller 2 to any other controller on the internal network just fine. And that anchor entry just stays put on controller 1. So a few things that we need to get going with this. Before we can get this up and running, we need that the internal controller and the external controller to be in each other's mobility group list. So usually the first thing you want to make sure of is you want to check the mobility domain name or group name, just depending on where you're reading this. It's called the domain name in the config, but most people refer to it as the mobility group name. You want those to be different generally because once we add these to each other's mobility groups list, if they share the same mobility group name, what's going to happen is the APs on controller 2 will learn about controller 1 as a potential controller to fail over to if we use the same name. Generally, you do not want your APs failing over from an internal controller to a controller in the DMZ. So the way to prevent that from accidentally happening is just make sure your domain names are different between your internal controllers and your controllers in the DMZ. So controller 1 will be my anchor controller. Its name is WLC1. Controller 2 is on the internal foreign. It's controller 2, so they do have different names. So I'm set there. Now add them to each other's list. So I'll go down to mobility management, mobility groups. And we just have to add them on both sides. So I usually like the edit all option here. This gives me a little easier copy paste. I just need to add in the other controller's mobility group name, so WLC2 in this case. And we'll apply. WLC1. Okay, so after a minute or two, these should move into an up status. If they don't move into an up status, it usually means you type something wrong, wrong MAC address, IP address, group name, or they're having communications issues. If you get them into a control plane up but data plane path down, most of the time that's something that goes wonky on the back end. You actually have to reboot the controllers to get it out of that state. At least in this code 70116, that's what I've run into. Okay, we have them in each other's mobility group list. The next step, let's get these guys using the exact same WLAN. So I already have it configured on WLC2. I need to get it configured on WLC1. Now it's very important when you configure it on WLC1 as well as any other controllers that are going to be working with this auto anchor system, they have to be configured as identically as possible. Because if there's any small setting changes, even one little checkbox on one controller can break the process of tunneling that client up to the DMZ controller. So typically what I'll do is I would either use something like a template from WCS or Prime Infrastructure or whatever management platform you're using. And that's one really easy way to make sure that it's identical across the board. Or I just kind of have them up right next to each other and I'm just configuring at the same time, and so I can reference page by page, we're trying to be as identical as possible. Now there's a few things that don't have to be the same. The WLAN ID can be different, so I'll just make this different for illustrative purposes. This number can be different, and that'll be fine. But let me get this guy up so I can just be doing some copy-paste work. So that's one difference that is okay. The interface that you select can be different, and that's okay. So I'll choose VLAN 11 on my anchor controller, the DMZ controller. WLC2, the internal controller, is VLAN 13, because oftentimes you have different interfaces in the DMZ than you would on the internal network, so that's understandable. Security though, everything under here has got to be the same. So what are we doing? We are doing web authentication. I'm going to take this Pre-auth ACL off. All right, looking identical there. I'm going to turn off the use of the radius server, although I think this might be one place where you can do differences, where you can have different radius servers listed, but all the checkboxes should absolutely be the same. So we're looking good there. So QoS, I believe I was under bronze. Again, screen by screen if you're doing this on a manual process, because one little checkbox can break this whole thing. And on advanced, so what did I do? I did DHCP required, I had a session timeout, different, and I believe peer-to-peer dropping blocked. Let's see, any discrepancies? All right, I think I'm identical. So we'll apply. Okay, last step. So I added them to each other's mobility group list. I've configured the WLAN as identically as possible with just the very few limited exceptions. WLAN ID, interface are the two most prominent ones that you can make difference. Now I need to configure this tunneling. So I need to configure it on both sides, both the foreign and the anchor. So on the foreign, if I go back out to my WLANs list, the little blue box over on to the right side, choose mobility anchors. And then it's going to ask us what is the IP address of the anchor controller. So I'm going to say it is 10.10.111.10, which is wireless LAN controller 1. Click on Mobility Anchor Create. So this is going to say, on this WLAN, send all the stuff over to controller 1. And I'm in a data path down. I might end up having to do a reboot. We'll see what happens here. Because it should have come up by now. All right, but then we'll do the same thing on controller 1, get into that mobility anchors entry. But it is the anchor switch, so we choose local on the anchor controller. But we need to make sure we do this on both sides, because if we forget this step on the anchor controller, the handoff won't happen and that EOIP tunnel won't be established. Okay, so this is up, so maybe it just was a timing thing. Let's check one more time real quick. Because it's got to be up on both sides of the equation. All right, well, this isn't going to work, so we'll just give it... We did get full up on controller 1, so usually I see it symmetrical, where if I get into this wonky state where the data path never comes up, I see the same thing on both sides of the equation. So I'll point out one other thing here while I'm hopefully waiting for controller 2 to come up. So before we saw, when we did that web redirect, it actually redirected it to the IP address of the virtual interface of the controller. So if I look at my URL, I got past it, but it was actually https:// an IP address. Instead of an IP address, if I wanted to actually get like a DNS name in there, you know, guest.yourcompany.com or whatever, so you're not showing them your virtual IP address, you can do that. It's a configuration in the virtual interface on, and it's going to be on the anchor controllers where it comes into play. So if I go into my virtual interface, I've pre-populated this because you're supposed to reboot anytime you make a change to the virtual interface. So I've kind of pre-done this so you don't have to suffer through a reboot. But just type in the DNS host name. So don't put HTTP or anything like that, or slashes or anything like that. It should just be a DNS name. So I pre-populated guest.proctorlabs.com. So when my client gets the redirect, instead of seeing the IP address in their URL bar, they'll see https:// guest.proctorlabs.com. Looks a little bit nicer. And this is also one of the steps required if you want to try to avoid those cert errors. You have to have a DNS name in your URL because the certificate is referencing a host name, and the host name is not the IP address. The host name is, should be guest.proctorlabs.com in this case. So in order to avoid the cert warning, this is one of the things that you will have to do. The other thing that you're going to have to do is to make sure that your clients can resolve guest.proctorlabs.com to the IP address of the virtual interface. That's going to be another thing you're going to need to avoid the cert warning. The last thing you're going to need is you need to install a cert that your guest clients are going to trust. And we'll get into that in just a second. So let's see if this guy ever came back up. Nope. All right, well, let me save config, and I'm just going to reboot this guy because I've seen it just stick in this data path down forever, and the only way to get out of it is a reboot. So once I get this rebooted, we can start talking about a few other things, and then we'll start demoing the process here. All right, commands, reboot, go for it. Okay, so while that reboots, I guess if you wanted to install a cert to avoid these cert warnings on your controller, on the back end you would have had to use something like OpenSSL to generate the CSR. You would send that CSR, which is a certificate signing request, out to VeriSign or GoDaddy or Thought or any of those already trusted third-party CAs out there. And then once you get the response back to install it, we're going to go back to Security, WebAuth, and then Certificate. So here we see the default self-signed certificate that was automatically installed. But if we want to install our own, we would just have to get the file into some sort of a TFTP or FTP server, and we check the box to download SSL certificate. And we just got to say, okay, where is it? What server is serving up this SSL certificate? the path to it, the name, and oftentimes there's a password associated with it, with the cert file itself. Type all that stuff in, it's going to snag it, install it, and after it installs, you will have to reboot the controller, but once the controller comes back up, now anytime we do a web authentication web page, it will use the cert that you just installed here. And this cert is different from the cert used for just GUI access. So, you know, the GUI administrative access I have here, that cert is actually a totally separate cert. So this cert is explicitly for web auth purposes. And there's, you know, for good reason, because, you know, the web auth is probably referencing this guest.proctorlabs.com or guest.yourcompany.com, whereas if you wanted to install a cert for GUI administration, that would probably be based off of the actual host name of the controller. So that's kind of why they separate it out. So if you want to try to avoid those cert warnings, the steps being on the virtual interface, define that URL. Within DNS, resolve the DNS name of the virtual interface to the IP address of the virtual interface, and then install a web cert that is generally trusted by everyone automatically. So something from a VeriSign or one of those trusted CAs out there. But if you have all those in place, that should prevent the cert warnings that are so very common on a guest network. All right, what else? Custom web pages. So if you wanted to install a custom web page, you know, we've just been using these sort of pre-canned, real generic-y web pages hosted by the controller. But if you want to do your own web page, the best place to start is if you go to cisco.com and you go to the downloads page for 5500 controller or whatever controller you want to use. One of the things you can download from within there is a web auth bundle, and they've got these pre-configured web pages of lots of different styles. You know, some of them are web authentication, some of them are pass-through, you know, this or that. And then all you need to do is just take the files that they've already created and then just edit the HTML of it. So just edit the text and edit the pictures and the look and feel of it. But they've already got the back-end code that's required for the actual authentication process. So, you know, can actually authenticate a user and send the results back, positive or negative or whatever it's going to be. So grab that and use that as a starting point, and then just tweak the visible part of the web page. And then once you have that, you actually have to bundle it into a tar file, and then you install the tar file on the controller. So to install that tar file, you go to Commands, and we're downloading a file, and it is a WebAuth bundle. And I have one already, 10.10.2.10, on my WCS servers, TFTP. And it's called wireless.tar. So what it's going to do is it's going to go ahead and download it, extract it, because it will have, you know, probably multiple files, and then they become available to use for web authentication. So it's grabbing it, it's extracting it. Okay. So I could then go to security, web auth, web login page, and flip myself over to just customized, downloaded. And now I'll use the customized page so we can kind of see what that looks like. Let's see, is controller 2 back up yet? Okay, it's back. Let's see if we got our tunnel up, or our mobility. Okay, now I'm up there. Let's make sure we're up on controller 1 real quick. Okay, so I think we should be good. So kind of getting back to that. So we made sure that the controllers were in each other mobility group list. We're in an upstate. We want to probably use different group names, though, to prevent those AP failover options. We configured the same WLAN as identically as possible with very few exceptions. And then we configured the mobility anchoring on both sides of it. So let's kind of see what it looks like once we're doing this. Okay. So I should have a fresh state. So let me look at the client session first. So once we're doing the tunneling, we're going to see the client session on both the foreign controller as well as the anchor controller. So let's look at that and see what kind of the differences are on the two different controllers. So first, the foreign controller. This is the controller where you know, the APs are at. So on the foreign controller, you know, we see Oh, why did it do that? Let me clear this out. Just make sure we're starting fresh. All right, so we have a fresh session here. We should see it on, okay, we're seeing it on both. All right. So internally on, okay, I guess I was just off. So on the foreign controller, now the foreign controller's WLAN is assigned to VLAN 13. So we see technically from the foreign controller, it's assigned to VLAN 13, but we're in an export foreign role. So we have sent this, this client's session out to the anchor controller, and we can see which anchor controller we sent it out to. So if we had multiple anchor controllers for redundancy's sake or whatever, it'll actually just sort of round robin. Every new client just gets sent to the next anchor controller on the list. So we can see which anchor controller we send it off to, 10, 10, 11, 10, which is controller 1. And we notice on the foreign controller, we're already in a run state. So that's one big difference you'll see. So on the foreign controller, you start off in a run state. Now what about on the anchor controller? This is going to look a lot more like what we've been seeing up to this point. So here we have the IP address on VLAN 11. So it pulls an IP address on whatever VLAN is assigned by the anchor controller. So we see it is on VLAN 11 there. We see it is the export anchor, so it has the anchor entry, but it is tunneling out to a foreign controller, and the foreign controller is tunneling out to is 10, 10, 1, 12, 10, so we can see that. And we are in that web auth required state. So this is more what we would expect to see. All right, let's go ahead and start the web authentication process here. So now what we should expect to see here is when we redirect, we'll redirect to a URL that says guest.proctorlabs.com instead of the IP address. And 2, we should see that custom web page. So let's go ahead and hopefully we'll see that. Okay, so it didn't like that. So we do see that it used guest.proctorlabs.com, but I ran into this for a specific purpose that I wanted to make sure that you understood is once in the URL, if we say, use a DNS name instead of just the IP address, we need to make sure that that DNS name actually, in fact, does resolve. 1, for cert purposes, if you're trying to avoid that, but 2, the web page actually won't even come up because now it's trying to resolve guest.proctorlabs.com. So if it can't resolve guest.proctorlabs.com to the virtual interface IP address, the web page won't even display. So what I need to make sure I do is on my WCS server here, which I happen to have up, I create in my forward lookup zone a new host record for guest.proctorlabs.com and matched up to 192.0.2.1. My whoops. Get the right IP address here. So we can resolve that. And the other thing that we need to make sure that we do is make sure that your clients, the guest clients, actually know about a DNS server that can resolve this. So this pretty much implies they have to be using your DNS servers internally. You can't just be pumping them out to Google's DNS servers because Google's DNS servers won't be able to resolve this. All right, now that I have that done, let's see if this works. Might have to start over here. I killed my browser. All right, let's try this again. Okay, so HTTP 192.0.2.1 should trigger the web redirect. Web redirect goes to guestproctorlabs.com. All right, it's not liking it. It could be a DNS issue here. So let me just check on my client. So ns lookup guest.proctorlabs.com. This DNS lookup is one of those things that we should be able to do. There it resolves. Let me try it one more time. Could be like a remembered failure or something like that. All right, let me try flush DNS. You can do it. Now we're starting to see the interaction of lots of different things kind of possibly causing the problem, but this is a little more, there we go. So now it's actually was able to resolve to it once I flushed its old DNS resolution cache. I'm still getting the cert warning because I don't have a trusted cert installed or anything like that. But I am getting the URL up there properly. Once it resolved to the virtual interface IP address, the page is actually able to display. And once this comes up, we should see that different page, which is the custom web page that I had from before. And in my case, it was a custom web authentication, so it should be prompting for a username password. And you only need to install a custom web page on the anchor controller because it's the anchor controller that's actually serving up the web page. And it's the anchor controller that's doing all the layer 3 authentication. So once we get this internal, external guest stuff going on, all layer 2 auth happens at the foreign controller, all layer 3 auth happens at the anchor controller. So if you had actually like an AO2.1x type network tunneling to a DMZ controller, the radius request would come from the foreign controller because that's a layer 2 auth. Anything layer 2 in foreign, layer 3 anchor. So now I'm getting a better page here. Down below I can see username, password. So I would need to make sure I actually have a username, password on here, so let me create one real quick. Let's call it guest. Oop. And then it should be all to auth. And I guess as long as this page was coded correctly, I don't know if it is. I haven't tested it. Should authenticate up and get me into a run state as long as this web page code is actually good. All right. So that's basic auto anchoring. Now a little bit of troubleshooting with that. If you, and once now that I get to that, I should see on my anchor controller I'm in a run state since I successfully authenticated. So the anchor goes through the normal DHCP required, WebAuth required run. On the foreign controller, you just pretty much go right to a run state. So you will see a little bit of difference depending on which controller you're looking at. Now, if you aren't seeing the client make its way to the anchor controller, you see it on the foreign, but you don't see it on the anchor. Here are the things to look for. 1, make sure that the controllers are added to each other's mobility group list. So you should see the anchor on the foreign side and the foreign on the anchor side, and it's made its way into an up status. Step number 1. Number 2, make sure that you have WLANs configured and that you have the mobility anchoring set on both sides. So on the DMZs, the anchor side, it's set to local. On the foreign side, it's referencing the anchor controller in that mobility anchors list. And then number 3, make sure your WLANs are configured as identically as possible. So just go screen by screen, what's different here? Anything? Okay, next screen, what's different here? If you go through those 3 things, typically you're going to find the problem of why the entry isn't making its way all the way over to the anchor controller. So a little bit of troubleshooting tip you can use for that. All right. We'll do one more feature and then I'll pretty much round it out, and then we'll just open up for questions if you have any. So with this mobility anchoring, if I had other controllers, let's say I wanted to do the same thing on controller 4, where controller 4 was an internal foreign controller and anchor to controller 1, I could do that. So let's do that real quick. I just need to just follow those steps that I just talked about. Make sure that we're in each other's mobility group list here. I'm going to add 1 to 4 and 4 to 1. Hopefully I don't run into that same issue on controller 4. And then I would configure the WLAN in controller 4, make sure it's identical to what's on controller 1. pull these up real quick. All right, so turn it on, and I'll just leave this on the management interface because it doesn't matter because I'm tunneling it. None. Web policy. Looks good. AAA servers should be nothing. QoS at bronze. Advanced, so it should be that. Session timeout and peer-to-peer blocking drop. All right, and then configure the auto anchoring. So mobility anchors. Controller 4 sends it over to controller 1. Controller 1 already is set to be the local anchor. So that should be pretty much it. Now, if I have clients that connect up to controller 4 or clients that connect up to controller 2, when they tunnel to controller 1, it's the same SSID, same WLAN. So they all will be pulling IP addresses on VLAN 13 or VLAN 11. But let's say I actually wanted to have different controllers or different foreign controllers, the guests get different IP addresses, different subnets. So, controller 2 clients could get VLAN 11 and controller 4 clients could get VLAN 12. That's the foreign mappings configuration. And you only have to do it on controller 1. So really all you do, is on the WLAN, you choose the foreign maps option, and then you just have a mapping of controller to VLANs. So you just need to figure out which controller is which because it just shows you the MAC address. But if I look at controller 4, so it's the one that ends in 6F00. Okay, so this is controller 4. So controller 4, I'll put them on VLAN 12, add mapping. And controller 2, I'll put them in VLAN 11. So this is going to override what you have configured just globally on the WLAN. And you would just repeat this process. So for every foreign controller, I could map them to a unique VLAN if I really wanted to. Excuse me. So now, if I connect up, so let's bounce my client here and then just see where it falls. All right, let's try to reconnect here. Well, supposedly it's connected, so I'll see if I can find it. All right, might have to disconnect and reconnect here. Okay, so it's trying to pull an IP address, but let's just see where it ended up. So on the DMZ controller, so we see it's coming from 10.10.112.10. So it's coming from wireless LAN controller 2. I would expect that it gets placed on VLAN 11. And it did, because that was where our mapping was. Now let's force this over to an AP on controller 4. I'll just shut down the VLAN, or the WLAN on controller 2. Just disable it. This will force the client over to controller 4. Looks like it's coming up. So now on my anchor controller, am I seeing it yet? Apologize for my sniffles here. All right, so here's the entry. All right, so it's not sending it off to the anchor controller. We don't see that mobility role of a foreign. So let's try to figure out what that is based off of the troubleshooting I gave. First, let's check the tunnel. Maybe the tunnel didn't come up, or the mobility. We might be running into the same issue. All right, so maybe I'm too quick on the trigger, or maybe I'm going to have to do that reboot again. But what I would have seen was now when it comes in from controller 4, it would set it to VLAN 12 based off of that foreign mapping. So it's a way to get clients on different subnets depending on which controllers they're coming in from on the same WLAN. So that's pretty much the things I wanted to show you about guest networking. Any questions about guest networking or anything I didn't talk about? Alrighty. Well, I mean, there's other things you can do with guest. Once we start getting ICE in there, you can get into stuff like central web auth and all the functionality that ICE brings, and that's a topic for a totally different day, and that's probably more of a topic for Peter, our security guy. But this is, the basics of guest here. Lots of things you can do, and just kind of watching the progress happening, how you're doing the different configurations and what they mean, things like that. So, really appreciate you guys' time. So definitely stay tuned for future sessions. We have it up on our blog. You should be able to find the different V lectures that we're going to be doing. I typically do one every month, and the topics that are going to be covered. So appreciate your time, and hopefully we'll see you next time.